So we've actually
Right.
scientists have found ways to take an adult cell, like a skin cell, right, from my arm and
Yeah.
find ways to kinda turn it back in time into a stem cell, and it wasn't that long ago that, like, the Nobel Prize went to the folks who like, came up with the factors that you needed to turn any cell right into a stem cell, so I feel like
Yeah.
really, yeah, how old is the stem cell field in terms of that?
Yeah, it's pretty recent, especially in talking like science timelines, right?
Right.
But yeah, now scientists can even take like your immune cells, like you just do a blood draw, isolate the immune cells and turn those into stem cells and use those to create your own tissue. So, for example, I have type 1, so I could take my own cells, turn them back into their pluripotent state by essentially just turning on certain genes that have been developed from that Nobel Prize and then creating my own pancreatic islet cells and transplanting them. But in the case of type 1 diabetes, it's a little complicated because it's autoimmune. So even using my own cells could
Mm.
be a little complicated because my immune system might be like, hey, like those are the same cells we killed. We got to kill those again. So it's already programmed to kill those types of cells. So in the lab for type 1 diabetes, at least, we're thinking of ways that we can gene edit these cells and try to make them immune evasive. So avoiding the immune system. I always like to use like
Uh,
the metaphor of if you guys know Harry Potter and he wears his invisibility cloak, but put our cells underneath that and they can hide from the immune system and produce insulin and essentially cure somebody of type 1 diabetes without them having to go on those harsh immunosuppressant drugs.